Hello everyone. Today what I'd like to talk about is some set theory basics. So, just to begin, a set is a collection of objects. And these objects can be just about anything. Here are some examples. Here in the first example we have A is the set 1 and B is just the set 2. Alright. Those are both sets. The next example, we have the empty set. So notice it's got these little it's just the same set braces from before, except there's nothing in there. Or another way of saying that is with this circle with a line through it. That's another way of denoting the empty set. The empty set is just a set that has no elements in it. Whereas in our first example, A had one element. A set with one element is called a singleton set. Alright, on to the next example. Here we have a set with a bunch of smiley faces, sad faces, surprise faces. You know, like I said, sets can have objects with just about anything in them. And this is perfectly mathematical. and next, our final example of a set here is the universal set. So the universal set, the way you want to think about it is it's everything that's under consideration when you're thinking about sets. So let's get into some set operations now that we've introduced what sets are and what could be in them. So for set union, the union of a collection of sets is the set of all elements in the collection. So it sounds like a word jumble, right? But it's actually pretty simple once we go through an example. And by the way, union, the union of two sets, or the union of any sets, any number of sets, is denoted by this U shape. All right. So now to our first set union example, we have the singleton set A is 1, and we have the singleton set B is 3. So we're unioning sets that each have one element in them. So A, so that's visible enough. A union B. So let's reread the definition of set union. The union of a collection of sets is the set of all elements in the collection. Well, this is my collection of sets. I have the set A and the set B. And the elements, the set of all elements in the collection, well, I have the element 1 and I have the element 3, right? There are no other elements in this collection. So therefore, the union of A and B in this instance is just the set 1, 3. Next, our second example has that A is the set 1, 2, and B is the set containing 2 and 3. So here, when we're talking about the union, we take everything from each set and shove it in here, right? Shove it into this union. So in this instance, we'll write 1 because 1 appears, right? We'll write 2 because 2 appears. So we got 1 and 2 covered. But also, we've got 2 here in the set B as well, right? Well, with sets, we don't repeat elements, and also the order doesn't matter. So because 2 appears in each set, we only write it once. We don't write it twice. So lastly, we've got the 1, we've got the 2. The last thing we need is this 3 here, and that will be in the set as well. So okay, so this covers, I left myself a little extra room here. I'll just cross that out. So yeah, that's A union B in that instance. So that's the first set operation I wanted to talk about. Next, the next set operation is set intersection. So the intersection of a collection of sets is the set of elements appearing in each and every set in the collection. It is denoted by this upside down, or this horseshoe, right? So now in this particular instance, for this example, the first example says that A is the set 1, 2, 3, and B is the set 1. So the intersection of a collection of sets is the set of elements appearing in each and every set in the collection. So here in our collection of sets, we have A is 1, 2, 3, and we have B is just the set containing 1. And now we want the set of elements appearing in each and every set. So what element appears in both A and B? Well, looking at this, we can see that 1 is in common between the two sets, right? So therefore, in this instance, A intersect B, because that's the only thing they have in common, is just the singleton set 1. So A intersect B, so think of intersect as what's in common between the sets. Whereas unions, you just kind of lump everything together. All right, the next example we have is where A is a set 2, 3, 4, and B is a set 2, 4. So, in this instance, A intersect B. So we look at what's in common. So I'm just going to circle what I see in both sets. Well, I see a 2, I see a 4, right? So those are the only two numbers that are in common between the two sets, the 2 and the 4, so that's the intersection. Last example, let's look at something that's a little bit more peculiar. So let's say that A is a set 1, 2. Oh, sorry, you can't see it on the screen. Let me pull that up. Sorry about that. So A is a set 1, 2, and B is the set 3, 4. So here notice that they don't share any elements, right? These are called disjoint sets. I'll note that on the side. This is just some terminology. When two sets don't share any elements, they're called disjoint. So A is the set 1, 2, B is the set 3, 4. Notice they don't have notice that they don't have anything in common, right? So that would mean that A intersect B because they have nothing in common. Another way of saying that is that A intersect B is just the empty set. I'll denote it both ways. Because there's nothing in common between them, right? So this set must be empty because there's nothing in common. Awesome. Well, I think that's it for this video. In the next video, we'll talk about set complement and relative complement.